Hello there. In this video, we're going to go through the next chapter in the Rust programming book. This is only kind of a single section. The last one had like 3 sections, but actually this one is going to be also pretty long, I think, because it's a bit of a longer piece. We're going to actually write a working Rust program, and we're just going to start at the top of this tutorial. We're going to program a guessing game. So let's jump into Rust by working through a hands-on project together. Nice. Man, this gives me so much nostalgia from the first time that I learned different beginnings of programming languages, like a bit of Python, a bit of R, a bit of Bash, if you count Bash, and Perl and stuff like that. This feels pretty good. I'm so excited to do this. So, this chapter introduces you to a few common Rust concepts by showing you how to use them in a real program. You'll learn about let, match, methods, associated functions, external crates, and more. In the following chapters, we'll explore these ideas and more these ideas, the same ones, in more detail. In this chapter, you'll just practice the fundamentals. Nice. We'll implement a classic beginner programming problem, a guessing game. You know, I think that actually one of my earliest games, if I can call it a game, was basically Battleship on a command line, where I would guess the square that the opponent's boats were on, and the computer program would guess the location of my boats, and just sink all of the boats and whoever won first type of thing. Very, very simple, but it was a great experience. No graphics, just like a, well, no, there's like text-based graphics, but let's just say they weren't good. Not great. Okay, so here's how it works. The program will generate a random integer between 1 and 100. It will then prompt the player to enter a guess. So we're already jumping into like user input. After a guess is entered, the program will indicate whether the guess is too low or too high. If the guess is correct, the game will print a congratulatory message and exit. We're here to get the gratifying experience of having a running program. There's something about beating a game that we wrote that is also like a horribly simple game that's based on chance that doesn't excite me, but yeah, we'll do the writing the program part. That'll be great. So we need to set up another project, set up a new project. So to set a new project up, go to the projects directory that you created in chapter 1 and make a new project using cargo like this. Doesn't really matter. I've set up my own path here. So let's follow guessing game. Great. So guessing game. Let's go in there. And as we've seen before, there's basically this cargo toml, and there's a main.rs file already made for us. But there's not much to it, right? So let's take a look at what they're going to say about the result of running cargo new. So the first command, cargo new, takes the name of the project, guessing game, as the first argument. The second command changes to the new projects directory. Look at the generated cargo.toml file. We got cargo.toml has the contents, and just to sanity check, of course, it's the same. We got guessing game. We got version 0.1.0 for our first version of this project, and we've got the 2024 edition with no dependencies added yet. Okay, so as you saw in chapter 1, cargo new generates a hello world program for you. Check out the source of main.rs. So we'll go through the motions here and spell main.rs correctly, and here's our hello world program. Just make sure that I didn't create a weird little file there. Great. So we could go cargo run, for example. Let's compile it, run it. There's hello world. Great. So the run command comes in handy when you need to rapidly iterate on a project. We'll do as we'll do in this game, quickly testing each iteration before moving to the next one. Now, if memory serves, we won't actually write any software tests, but this is like manual testing. So reopen the source.main.rs. You'll be writing all the code in this file. Sure. Now we're in. Not much in there yet. Okay, processing a guess. The first part of the guessing game program will ask for user input, process that input, and check that the input is in the expected form. To start, we'll allow the player to input a guess. enter the code in listing 2-1. Let's do it. Let's do it. So the first thing is we're actually going to include something from the standard library from IO, which is probably input output. So we'll go print line macro and we'll say guess the number. I guess that's sort of the name of the game here. And then we'll also do print line macro, please enter or input your guess. And then we'll create a mutable variable guess, and it will be initially assigned the value of a new string. Now there's a whole business, and maybe they'll describe in the tutorial about this. We'll see about like why is there stir versus string versus some other things in Rust. But for now, we'll just take that in stride. Standard in, and go read line, and we'll create a mutable reference to guess, which I'm not sure if we've covered. My brain's drawing a blank on whether we covered this already in the Hello World tutorial. Probably not, but we're going to get there. But suffice to say, I'm going to say the thing that I understand currently, which is that this is we're passing a mutable reference to guess. Now, expect failed to read line. This is really just going to run if there was some problem, some error that came up in reading the line, that we can expect this message. Not expect the message, but when an error occurs, it's going to show that message, and I think possibly panic. Possibly panic. Okay, and then we'll say you guessed, and we'll give a formatted print of the guess. Okay, let's read what they say about what's in this code. This code contains a lot of information, so let's go over it line by line. To obtain user input and then print the result as output, we need to bring in the IO, the input-output library, into scope. You bet. The IO library comes from the standard library known as STD, or usually people pronounce it as standard, not to be confused with sexually transmitted diseases. By default, Rust has a set of items defined in the standard library that brings it into scope of every program. This set is called the prelude, and you can see everything in it in the standard library documentation. So I don't think we'll do that now, but suffice to say, it's good to know that basically there's things you can bring in from the standard library, and then there are things that are part of the prelude that get included in every Rust program. So accessing what's in standard IO is grabbing something from the standard library. It's not part of the prelude. And that's why we needed to bring it into scope, so that we can use it. So next thing is, if a type you want to use isn't in the prelude, you have to bring that type into scope explicitly with a use statement. Using the standard IO library provides you with a number of useful features, including the ability to accept user input. As you saw in Chapter 1, the main function is the entry point into the program. So there's our fun main. And the fun, or fn, syntax declares a new function. The parentheses indicate that there are no parameters. And the curly brackets start the body of the function and also end it eventually. As you learned in Chapter 1, the printline macro, or printline bang, is a macro that prints a string to the screen. So guess the number, please input your guess. I don't think it'll let me run this. No. Some of these kinds of Rust books actually let you run the snippets of code. Okay, so this code is printing and a prompt stating what the game is and requesting input from the user. It hasn't asked us to actually run the example yet, but I am curious if we cargo run. Okay, it's just doing the printing. Interesting. I mean, is that because of where I'm in my IDE though? Cargo run. Please input my your guess. Let's put in 34. You guessed 34. Okay, so I'm gonna have to hop out of this editor environment when I want to actually run and get user input stuff. Let's actually just exit out of this one, and then we'll create another one in the same path. How about that? So that we can quickly hop back and forth. Okay, so next up, storing values with variables. Next, we'll create a variable to store the user input like this. So that's this let mute guess. Guess, we're going to store the guess from the user inside a variable called guess. Now the program is getting interesting. There's a lot going on in this little line. We use the let statement to create the variable. Here's another example. Let apples be assigned the value of 5. This line creates a new variable named apples and binds it to the value 5. In Rust, variables are immutable by default, meaning once we give the variable a value, that value won't change. In my opinion, for the kind of use cases that I have in mind of like technically correct implementations of an algorithm that have lots of quality control checks and lots of guarantees about type safety, Rust is actually a really great language for this type of thing. There are scripting languages where maybe you don't have to be quite so careful about mutability and immutability. So for example, coming from Python, just about every variable, especially user-defined variables within a Python session, or even defined at runtime from a script or a library or whatever, the variables that are usually defined in Python are all mutable references. And so even if you're dealing with immutable data types, you can still kind of just replace almost anything. You know, what happens at runtime stays at runtime. This is a very different song that we're singing with Rust, where we're going to put guarantees on the correctness of things. So anyway, I think that immutability by default is pretty good for a language like Rust. We'll be discussing this concept in detail in the variables and mutability section in chapter 3. To make a variable mutable, we add the mut, or what I guess some of us pronounce mute, before the variable name. So here we've got like let apples be bound to the value of 5 is immutable, where let mute bananas equals 5 is going to be a mutable variable. So the little note here says that the // syntax starts a comment that continues until the end of the line. Rust ignores everything in comments. We discuss comments in more detail in chapter 3. Sounds good. Does sound good to me. So returning to the guessing game program, you now know that let mute guess will introduce a mutable variable guess. The equal sign, equal, tells Rust we want to bind something to the variable now. On the right hand of the equal sign is the value that the guess is bound to, which is the result of calling string new, a function that returns a new instance of a string. String is a string type provided by the standard library that is growable, and UTF encoded as well, so not just plain ASCII. Okay, I don't think we're going to read through that, but you can see what they mean about like the UTF-8 part. There's no way you could have this, I don't know what it is, sparkly heart or whatever. It's definitely not an ASCII character. So, okay, that's great. And the, what did they say, expandable? Like it's not a fixed growable, that's the word they used. It's not a fixed size data type. So by and large, if I remember right, that means it's going to be a heap allocated data structure rather than a stack allocated data structure. And I think that probably comes up later in this book as well. Okay, so let's understand that syntax a little bit more. We got that string : new, and they're saying this, the : syntax in the : new line indicates that new is an associated function of the string type. An associated function is a function that's implemented on a type. In the case string, in this case string. So associated functions, especially if they're associated to something that, well, not a class because there aren't classes in Rust, but something that's kind of object-like or thingy is what associated functions are basically like. They're kind of like class methods, but of course, no classes, no inheritance. So this new function creates a new empty string. You'll find a new function on many types because it's a common name for a function that makes a new value of some kind. And that's probably a good convention to stick to, is to say you got a thing, and then you want to declare that you're making a new version of that thing or a new instance of a thing. I don't know if I'm allowed to say instance exactly, but we'll go with it. In the full, the let mute guess string new line has created a mutable variable that is currently bound to a new empty instance of a string. Okay, they use the word instance. That makes me feel comfortable, so we'll call it an instance. just not an instance of a class, an instance of a different kind of data type like structs and enums and things. We won't get into that right now. So, receiving user input. Recall that we included the input-output functionality from the standard library with useStandardIO on the first line of the program. Now we'll call the standard-in function from the standard.io module, which will allow us to handle user input. So here's that snippet of code of I/O, and we're accessing that function standard-in, and then we're also calling a chained function, I guess. I can't call it a method, but it's a kind of a chained, an additional function that will get called that takes in a mutable reference to guess. If we hadn't imported the I/O module, the useStandardIO with useStandardIO at the beginning of the program, we could still use the function by writing this function call as standard.io standard-in. The standard-in function returns an instance of standard.io standard-in. So note the capitalization there of the standard-in there, as opposed to this small case of saying the small case standard-in is something that's going to help create an instance of the capital S standard-in. Okay, which is a type that represents a handle to the standard input for your terminal. Nice. So next, the line.readLine, passing in a mutable reference to guess, calls the readLine method on the standard input handle to get the input from the user. Yeah, this is like, I mean, in Python, it's very much like using this input your guess or whatever, right? And then you could say 34 or whatever, right? Like it's just grabbing some user input. So we're also passing ampersand mut guess as arguments to the read line to tell it what string to store the user input in. The full job of readLine is to take whatever the user types into standard input and append that into the string without overwriting its contents. So we therefore pass that string in as an argument. That's actually, I wouldn't say it's like useful to know right now, but I kind of feel like that would be a nuance that eventually is useful to take advantage of, where I mostly just want to like start with an empty string and basically replace it, but appending to an empty string is like replacing the empty string with a non-empty string, where in general I might say, well, I've got this like collected up sequence and I'm building it up piece at a time from some inputs that maybe you want to take advantage of the fact that that's going to append to it and not replace it as a matter of implementation details. So where were we? So that therefore the string argument needs to be mutable so the method can change the string's contents. Yeah. Mutable means changeable, and if you don't allow something to be mutable, then you can't change it. So the ampersand indicates that this argument is a reference, which gives you a way to let multiple parts of your code access one piece of data without needing to copy that data into memory multiple times. References are a complex, and I think we'll probably come back to this later, probably in like ownership, references, and borrowing, of like how many mutable references can you have? Only one. How many immutable references you can have? Well, if they're all immutable, the answer is only well, any number. But mutability is important. So you kind of have like a mutex on every variable. We'll get to it. So references are a complex feature, and one of Rust's major advantages is how safe and easy it is to use references. You don't need to know a lot of those details to finish this program. For now, all you need to know is that, like variables, references are immutable by default, which is good. I think that's mostly good. So hence you need to write ampersand mute guess, or reference to mutable reference to guess is maybe how I try to say it in words, rather than ampersand guess, to make it mutable. Chapter 4 will explain references more thoroughly. Okay. Okie dokie. So this is like a lot of just explaining. We didn't actually write all that much code, but it really starts to speak to what they're saying earlier on, of like there's a lot going on here. In terms of the amount of code, this isn't really a lot of code, but to really explain what's going on here from the beginning or close to the beginning is a fair bit, right? So we're still working on this line of code. We're now discussing a third line of text, but note that it isn't. That it's still part of a single logical line of code. The next part is this method, the dot expect. Interesting that they called it a method, because it's like it's not just a well, it's not a class, right? And so there's no like, it's not really like an instance method. It's not a class method, but it is like a thing method. It's a function that's associated to something, and it may or may not have a reference to self. I don't know. Okay, so expect failed to read line. Okay, we could have written this code as the following: io standard in dot read line passing in mutable reference to guess dot expect failed to read line. However, one long line is difficult to read, so it's best to divide it. It's often wise to introduce a new line and other whitespace to help break up long lines when you call a method with the .name method syntax. Yeah, and Python also strongly emphasizes whitespace just to keep things visually organized, even if you don't strictly speaking have to. Now, let's discuss what this line does. As mentioned earlier, readLine puts whatever the user enters into the string we pass to it, but also returns a result value. So this capital R result is an enum, or enumeration. Oh, I just said it in the backwards order. Enumeration, often called an enum, which is a type that can be in one of multiple possible states. Yeah, like I like to think about enums as a way of canonically defining some set of values. We call each possible state a variant. Okay, it's a name. What's in a name? So Chapter 6 will cover enums in more detail. The purpose of these result types is to encode error handling information. So results variants are twofold. You've got OK, which sounds it is what probably it sounds like, and error, or error, which is also probably what it sounds like. The OK variant indicates the operation was successful, and it contains the successfully generated value. The error variant means the operation failed, and it contains information about how or why the operation failed. Values of the result type, like values of any type, have methods defined on them. An instance of result has an expect method that you can call. Good to know. So the expect method is something that's on a kind of instance of the result type. Interesting. Yeah, I guess it makes sense. Okay, so if instance of result is an error value, expect will cause the program to crash and display the message that you passed as an argument to expect. It kind of reminds me of like assertions almost in Python, where you can include a little message that says why an assertion failed. Okay, so if the readLine method returns an error, it would likely be the result of an error coming from the underlying operating system. In this case, yeah, for like this program. Maybe not in general. Kind of depends on what you're getting an expect from, but yeah, here that makes sense because it's coming from standard in, which is this, I assume, well-written library that probably doesn't have an issue. And so maybe it's like a compatibility with the OS kind of thing going on, or some invalid state that the OS got into. Just guesses. So if this instance of result is an OK value, expect will take the return value that OK is holding and return just that value to you so you can use it. Okay, nice. That's right, because you kind of have like an extra level of indirection where you kind of need to get the returned result out of the result type of thing. Okay, in this case, that value is the number of bytes in the user's input. If you don't call expect, the program will compile, but you'll get a warning. Okay, let's try it. Actually, just real quick. Let's go cargo run after just commenting that out. And yeah, we get this. This could not compile due to one previous error, and the error is pointing to this, standard IO business. Going back to all the way to like guess. Oh, no, this is actually slightly different error, isn't it? Because of the fact that I didn't put on a... Okay, now my error is looking like theirs much more closely to go. Okay, this is an unused result, is the warning I'm getting. So technically it compiles, but I may get... well, what would happen here without the... I guess if I tried to do anything with the result, that could cause errors. And at the moment, I'm not doing anything with it. Oh, I am. No, I'm printing it. So I wonder what happens. Is there an invalid input that I could make here? I don't know. I'm not sure how to break it just yet, but I'm sure eventually we'll know ways. Okay, so let's reset this back to what the tutorial wants it to be. Okay, we're back. Rust warns you that you haven't used the result value returned from the read line, indicating that the program hasn't handled a possible error. Okay, that's fair. And I think that's good, actually. So I think you should handle all the error cases. The right way to suppress the warning is to actually write error handling code. But in our case, we just want to crash the program when a problem occurs, so we can use expect. Okay, yeah. I don't know if that's like just for prototyping or if that's also something where if you wanted something to be fail fast, even in production, which is, depending on the type of thing you build, may or may not be desirable. I don't know. I'm curious. So you'll learn about recovering from errors in Chapter 9. All right. Printing values with the print line macro placeholders. Aside from closing the curly brackets, there's only one more line to discuss in the code so far. Print line macro, you guessed, guess. This line prints the string that now contains the user's input. That's the same guess we pulled out of the standard in. The curly bracket set, the set of curly brackets is the placeholder. Think of the curly brackets as little crab pincers that hold a value in place. I don't think I will, but thanks. Okay, so when printing the value of a variable, the variable name can go inside the curly brackets. When printing the result of evaluating an expression, place empty curly brackets in the format string. Then follow the format string with a comma-separated list of expressions to print in each empty curly bracket placeholder in the same order. Sounds good. So printing a variable in the result of an expression in one call to print line macro would look something like this. Yeah, okay. So if I just quickly override, or let's just comment it out, actually. Oops. GC, that's the one. Okay. We can run this new little suggested program here. What are they saying? We got let x be bound to the value of 5 and let y be bound to the value of 10. And then print line macro, we can say x. This is not yet referring to the actual x value in the program. The second one is, that's in the curly brackets. And y plus 2, also not directly referring to the actual values in the program. But here we've left it as an empty curly brackets, but we're putting the y plus 2 here instead. So then if we cargo run, there's there's our little printout, x equals 5 and y plus 2 is equal to 12. All right. So let's just undo that. We're back where we were. So this code prints what we just talked about. That makes sense. That's good. So testing the first part. Let's test the first part of the guessing game. Wow, they did a lot of explaining before they told us to run this thing. So cargo run. If we put in our guess to be 6, we should get 6. It's probably good to just quickly do a rerun because I changed code and hopefully saved. Yeah, yes, there we go. At this point, the first part of the game is done. We're getting input from the keyboard and then printing it. Now I think we're going to make some modifications. So we're going to go into making some random numbers. Let's do it. So what does it say about this? Generating a secret number. Next, we need to generate a secret number that the user will try to guess. The secret number should be different every time, so the game is fun to play more than once. I don't know if this game is fun anyway. Can I say that? It's not a great game. It's a good game to program as like an intro programming problem. We'll use a random number between 1 and 100 so the game isn't too difficult. Rust doesn't yet include random number functionality in its standard library. However, the Rust team does provide a rand crate with said functionality. Cool. So to recap, we had already just talked about two ways that things can be available, right? There's the prelude of stuff that gets included in every program. Then there's the standard library where you can bring stuff in and it's always available with Rust. It comes with Rust. Now we're talking about crates, which are kind of like packages where it doesn't come with Rust. We need to make some further instructions to go get it. So, using a crate to get more functionality. Remember that a crate is a collection of Rust source code files. Okay. Do I remember that? Yes. Did they say that earlier in these tutorials? I'm not sure. I can't remember. The project we've been building is a binary crate, which is an executable. The rand crate is a library crate, which contains code that is intended to be used in other programs and can't be executed on its own. I think the answer is yes from my reading, but it's been a while. I think you can have both. Like, I think you can have something that is both a binary crate and a Rust crate. Just like when you're writing a Python package, you could have a main and actually use the package itself like a command line tool. You could write, using argparse or optparse or click or whatever, your own CLI, but then it's also a library you can import stuff from. We shall see. We shall see. So Cargo's coordination of external crates is where Cargo really shines. Before we can write code that uses rand, we need to modify the cargo.toml file to include the rand crate as a dependency. Open that file now and add the following line to the bottom beneath the dependency section header under Cargo header that Cargo created for you. Be sure to specify rand exactly as we have it here with this version number, or the code examples in the tutorial may not work. So I should do what I'm told, but I thought you could do something like cargo add. Am I wrong? Or am I getting other tools confused? Yeah. I think you can just add it. And so it like adds it to the cargo toml for you. Now, okay. It did get it, but it got the wrong version. So I'm actually going to do the thing where I delete the lock file. And then we're going to go into the cargo. And we're going to set it to the version that they want it to be. I don't think this example should break using the other version that we had. But you know what? Let's just stick to the beaten path. I just wanted to see. Like I think that's usually the way I would add a package with cargo is to... is to cargo add it. Okay, anyway, let's follow the instructions here. So we made this change, rand equals 0.8.5. In the cargo toml file, everything follows a header. Everything that follows a header is part of that section that continues until another section starts. Okay, basic parsing rules of this file format. In dependencies, you can tell cargo which external crates your project depends on and which versions of those crates you require. Nice. In this case, we specify the rand crate with the semantic version specifier 0.8.5. Yeah, there's the semantic versioning. Is this the same 2.0 that I'm aware of? Yes, it is. Okay. We talk about this in the Python world all the time. Okay, so Cargo understands semantic versioning, sometimes called semver, which is a standard for writing version numbers. The specifier 0.8.5 is actually shorthand for caret 0.8.5. Has nothing to do with the kind of carrots that you might eat or provide to little, bunny rabbits or whatever. But caret, it's kind of an up symbol, which means any version that is at least 0.8.5, but below 0.9.0. Interesting. So it will still remain within the same major release, so it should never go to another major version and therefore possibly break stuff. Hopefully. Fingers crossed, but there could be bug fixes. So if you... What is that XKCD? It's like the one where the person, like some user is depending on like a bug of how the heating system works or something or rather. what is it? Hanlon's law. Is that right? Goodness me. XKCD. Maybe I got this right. Maybe not. No, they're doing some Occam's razor thing. No, it's a guy's name, starts with H, but I can't remember what it is right now. Anyway, there's a funny little meme. Okay, so Cargo considers these versions to have public APIs compatible with version 0.8.5, and this specification ensures you'll get the latest patch release that will still compile with the code in this chapter. Any versions of 0.9.0 or greater is not guaranteed to have the same API as what the following examples use. That's fair. But we're good. We're using the right one. So now, without changing any of the code, let's build the project as shown in the listing. So sure, let's build it. Cargo build. Look at that. Look at that massively slow compiling speed. It's fine. Okay, so we built it. You may see different version numbers, but they will all be compatible with the code thanks to Semver, and different lines depending on the operating system. And the lines may be in different ordering. Okay, so there's some like algorithmic details that they're basically saying, don't worry about it. When we include an external dependency, Cargo fetches the latest versions of everything that dependency needs from the registry, which is a copy of data from crates.io. Crates.io is where people in the Rust ecosystem post their open source code, their Rust projects for others to use. That's what I ended up doing myself with Desra Rust, is that it lives on crates.io. Now, it might sound like I'm trying to say go use my package, but this package actually still needs more work. So pull requests would be nice, but oh no, look, downloads. Okay, anyway. After updating the registry, Cargo checks the dependencies section and downloads any crates listed that aren't already downloaded. That's smart. So you're like locally caching stuff so that you're not downloading everything every time. Perfect. So in this case, although we only listed Rand as a dependency, Cargo also grabbed the other crates that Rand itself depends on. After downloading the crates, Rust compiles them and then compiles the project with the dependencies available. Nice. So if you immediately run Cargo build, again, without making any changes, you won't get any output aside from the finished line. Let's see if that's true. It's basically true, yes. Look at that. What was it before? It was almost 2.5 seconds. And here it's like 0.03 seconds because it's not actually doing any work. What if I do like build release? Then it's going to take even longer than 2.5 seconds. Yeah, it took 2.85 seconds. But then if I go again, it's similarly very small. Awesome. Oddly enough, not doing a task again takes less time than doing the task again. Okay, so Cargo knows it has already downloaded and compiled the dependencies, and you haven't changed anything about them in your cargo.toml file. Cargo also knows that you haven't changed anything about your code, so it doesn't recompile that either. With nothing to do, it simply exits. Nice. If you open the source.main, source/main rs file, make a trivial change, and then save and build again, you'll only see 2 lines of output. Okay, I'm not sure I was counting the lines of output all that carefully, but here you could see this is where all the packages were being compiled, but they've been compiled and they're fixed version numbers, so you don't need to compile them again. So that's very nice. This line shows that Cargo only updates the build with your tiny change to the main rs file. Your dependencies haven't changed, so Cargo can reuse what it has already downloaded and compiled for those purposes. Ensuring reproducible builds with the Cargo lock file. This is like the grown-up territory of, look, reproducibility is one of those things that maybe isn't the most exciting thing when you're first learning programming, but is like this huge headache-saving thing in the real world. Okay, so Cargo has a mechanism that ensures that you rebuild the same artifact every time you or anyone else builds your code. Cargo will use only the versions of the dependencies you specified until indicated otherwise. For example, say that the next week version is 0.8.6 of the RAND package comes out, and that version contains an important bug fix, but it also contains a regression that will break your code. That would suck. To handle this, Rust creates the cargo lock file the first time you run the cargo build, so we now have this in the guessing game directory. Right. We did see this because I deleted it the first time when I was playing around with stuff. So this is a bigger picture view of all the dependencies, right? We just thought we grabbed RAND, but RAND actually depends on a bunch of things like this, I don't know, config if. I'm not really sure what that is. We could, in theory, we could go chase down what these things are, get random. This is our package. And so in the dependency graph, it actually depends on RAND, but you know, it goes back from the thing you're building to all the other things. And here we've got libc, ppv-light86, proc macro 2, quote, and there's RAND. And then there's all, you know, it depends on these, libc, RAND, chaka or cha-cha, RAND core, and RAND cha-cha, RAND core. So anyway, could go on and on. But the basic information here is, for the most part, you know, what's the name, what's the version, what's the source, where did it come from, a checksum to make sure that it really is the same thing that you've downloaded again, and then these dependencies so that you can build a dependency graph out of it. Because, well, figuring out what packages you can use, what combos of packages are allowed, consistent, whatever, and also just downloading all the things you need, rely on knowing what those dependencies are. Okay. Great. So when you build a project for the first time, Cargo figures out all of the versions of the dependencies that fit the criteria and then writes them to the cargo lock toml file. Blah, blah, blah. Cargo lock file, not toml. Although I think that was a toml format, if I am not mistaken. When you build your project in the future, Cargo will see the cargo lock file exists and will use the version specified there, rather than doing all the work of figuring out the versions again. It's all about saving work, all right? And this lets you have a reproducible build automatically. In other words, your project will remain at 0.8.5 until you explicitly upgrade, thanks to the cargo lock file. Because the cargo lock file is important for reproducible builds, it's often checked into source code with the rest of your code. I haven't done like a huge number of Rust projects, but I do that every time. Just seems like the easy, right thing to do. Anyway, updating a crate to get a new version. When you do want to update a crate, Cargo provides the command update, which will ignore the cargo lock file and figure out the latest versions that fit your specifications in the cargo toml. Cargo will then write those versions to the cargo lock file. In this case, Cargo will only look for versions greater than 0.8.5 and less than 0.9.0. If the RAND crate has released the two new versions, 0.8.6 and 0.9.0, you would see the following cargo update. Let's do it. Cargo update. Okay, 0 packages to the latest Rust compatible versions. Okie dokie. Well, it was worth a shot. Anyway, I don't think it did update to... Oh, yeah, right, because that would be the next one up. I see. Okay. So to use RAND version 0.9.0 or later, or any version of the 0.9.x series, you'd have to update the cargo toml to look like this instead. Okay, so you could start with the 0.9.0 and then go cargo build or cargo update. Okay, so the next time you run cargo build, cargo update will update the registry of crates available and reevaluate your RAND requirements according to the new version you have specified. There's a lot more to say about Cargo and its ecosystem. What are they linking to with ecosystem? Oh, just all the crates that are out there on crates.io. The things, you know, which we'll discuss in chapter 14. But for now, that's all you need to know. Cargo makes it very easy to reuse libraries, so Rustaceans are able to write smaller programs that are assembled from a number of packages. Sweet. I'm not sure if the tutorial expects us to update this number. Maybe we'll do it real quick. Yeah, tab new, cargo, pommel. So we'll write that, and then we'll run another cargo. I guess we could do the build. Why not? Interesting. I'm not sure if it really updated anything or not. If I go cat cargo dot pommel cargo update. Yeah, okay. No, I guess it's just happy with that. All right, that's fine. The next time you run cargo build, cargo will update all the things. I think I said that. There's a lot more to say about cargo ecosystem. I said that as well. Okay, let's generate random numbers. Time to generate the numbers that are random. Let's start using rand to generate a number to guess. The next step is to update the source main RS as follows. Okay, so what's different in their code? They are bringing in the rand crate. So we'll go use rand. Those coming from Python, it's like the use statement is kind of like the import statement. The mechanism behind the scenes is different, but okay. And we're getting a warning here from my editor just saying we haven't used it yet, but that's fine. You may have also noticed that the formatter also decided to reformat things. It's not a big deal here. I don't think that the using order, the import order is important here. Okay, so what's next that's different? We got the guess the number, and then we're inserting some lines in between here. So we got the let secret number be bound to whatever the value of rand, and we're grabbing a thread random number generator and getting gen range. We're generating a number in the range, I think. That's my inference. We'll close that statement. Interesting. We're getting a deprecation warning in the main tutorial. What is it? What does it say? Use of deprecated function rand thread RNG renamed to RNG. So should I just do that? Renamed to random range. And now we're back to an unused variable. Ooh, but do I want to deviate from the tutorial? It's probably fine to stick with what they've got there, even though it is deprecated. Because deprecated here is not going to break it. It just means that officially there's another way to do this, and they just haven't updated the tutorial to represent that. So I think we're going to continue with what we're going to do what we're told, and it will probably work out fine. But, you know, we can fix it if we have to. Also, aren't the hints wonderful? It's just like it told me enough to basically fix the issue. It's pretty great. Okay, so the other thing is we're going to have this additional print line macro statement. The secret, spelling transpositions, the secret number is, and then we'll put in here secret number. Close that statement off. Anything else they're changing on us? There's our guess, read line, expect, you guessed, blibbity blabbity. Okay, nope, that's it. So this line, my prediction for what they're going to tell us, I should really turn those notifications right off. There we go. So this line, getting secret number, is generating a random number between 1 and 100. All right, so first we add the line use rand RNG. The RNG trait defines the methods that random number generators implement, and this trait must be in scope for us to use those methods. All right, that makes sense. Chapter 10 will cover traits in more detail. Yeah, I don't think we're ready to talk about traits. So Next, we're adding 2 lines in the middle. In the first line, we call the rand thread RNG function that gives us the particular random number generator that we're going to use. One that is local to the current execution, thread of execution, and is seeded by the operating system. Okay, so that's what the whole threading thing is about. At first I was kind of like, why is the word thread in the name of a random number generator? But that right there, I guess, is a clear enough explanation now. Good. Then we call the gen range method on the random number generator. This method is defined by the RNG trait that we brought into scope with the use of rand RNG statement. The gen range method takes a range expression as an argument and generates a random number in the range. So the generator range expression here is the 1 ... equals 100. You can use these for loops, for example. You could go for I in, what is it, 1 ... Sure, let's do secret number. Why not? Print all the numbers up to and including secret number, or just up to and not including? Not including. What are you telling me, Rust? Print line macro underscore can in expressions underscore can only be used on the left hand side. Where did I use? Oh, just there. Just accidentally added one. Cargo run. There we go. So there's actually, you think about what I actually just wrote for the code. I did not go 1 through whatever I did. I actually just printed the secret number itself a whole bunch of times. So guess the number, and then it printed 1. The secret number is 2. Well, this is an interesting bug we've come across. No, it's not a bug. Sorry, the secret number was actually 1. That's fine. Or is it fine? Am I getting some weird, please input your guess? I put in 2. This is fine. I did put in 2. But why would it print 1 after guess the number? The secret number is 2. Oh my goodness. I just can't do basic logic today. You know what it is? It's just the secret number is 2, and you know what? There's only one number that comes before 2, between 1 and 2, so we're done. Just not thinking about it enough. But anyway, all right. The point of that was just to show you that you got 1 to 100 can be represented with this ... type of notation. Well, I think with the equals means equal to. Maybe I'll go back and double check that hypothesis, and then if I'm wrong, we'll just move on anyway. There we go. So the secret number is 63, and this time it actually did print up to and including 63. And then, I don't know, we'll put in 63. My guess is 63, prints out 63. We're all happy and good there. All right, let's stop that detour and get back onto the right track here, the path of light of reading the documentation. The kind of range expression we're using here takes the form of start ... equals end. Like, why do I even try to explain it? It's like the documentation's just going to tell us, and is inclusive on the lower and upper bounds. So we need to specify 1 ... equals 100 to request a number between 1 and 100. Inclusive. So, little note here. You won't just know which traits to use and which methods and functions to call from a crate. So each crate has documentation with instructions for using it. Are you telling me we got to read the documentation? Dang, I guess that makes sense. Another neat feature of Cargo is that running cargo doc -- open command will build documentation provided by all your dependencies locally and open it in your browser. If you're interested in other functionality in the rand crate, for example, rand cargo doc -- open and click rand in the sidebar on the left. Oh yeah. I am curious. I think I got some kind of error the last time I tried to do this. No, it looks like it's building it. Yeah, no problem. I must have been thinking of something else. So you got, we don't have actually all that much. We got our main function, and the main function is private, and so the documentation is not really showing us anything about main. I wonder if we can just go straight to making it. Is it pub fun or fun pub? Now we can look at main, I think. Can we look inside of main? There's inside of main. There's our program. But there's not really a lot of the bells and whistles in this really basic documentation until we start opening up some of the stuff with the related crates. Remember, we looked in that lock file and there's all that stuff in there? Well, this is the stuff. So there's our quick start. And quick starts, of course, are nice for, well, quick starting. So, I mean, you can see where things have changed, right? They got the RAND, and now it's in like a prelude of some kind, but it's not maybe the global Rust prelude. I'm not sure. Honestly, I'm not sure. And then get an RNG, let mutable reference RNG, RAND, accessing an RNG constructor thingy bobber. Oh, right. That's enough of that. But yeah, basically you can look at your documentation. So this is, again, one of the things I think is just wonderful about Cargo is if you're just getting started with Rust, it kind of is pretty close to a one-stop shop of various things that you need to use in order to do programming with Rust, in order to do development with Rust. You don't have to go, right, do I need a formatter? Do I need a linter? Do I need a test runner? Do I need a dependency manager? Like all of these things, the answer is yes. And oh yeah, by the way, do you want to generate documentation from your project? Yeah, Cargo has got your back. So I think that's pretty great. The second new line prints the secret number. This is useful while we're developing the program to be able to test it, but we'll delete it from the final version. Yeah, like if we're printing it to the user, it's not really much of a secret, is it? Is it? It's not much of a game if the program prints the answer as soon as it starts. Yeah. So I don't know. Are they asking us, are they inviting us to run the program here? We'll Cargo run, getting some warnings. Oh, it's the deprecation warning. That makes it more tempting to fix it. Or I could turn off the warnings using a, I could turn off the warnings with this this macro. I don't know if I want to right now. Anyway, okay, so let's put in, I don't know, 4 like they did, prints it. We could run it again, put in 5, prints 5. Okay, you get the idea. So you should get different random numbers, and they should all be numbers between 1 and 100. Great job. So far as we saw, they were all between 1 and 100, so that's a win. Compare the guess to the secret number. Now that we have user input and a random number, we can compare them. That step is shown in listing 2-4. Note that this code won't compile just yet, as we explain. So there's that little crab thing, if I remember right. The crab with the question mark means, yeah, does not compile. There it is. This code does not compile. Okay, so one of the things they did here, I'm noticing, is they put in little snip. And so they're basically saying we're going to get rid of some of the code just so that it's easier to read in the tutorial instead of copying larger and larger chunks of code, but we're going to keep all that code in ours. So what's different in their code? Well, they included this ordering crate. So we're going to do the same standard standard CMP, I think, is for compare, and ordering. And it's automatically sorting our imports like a boss. So we'll move back down to the, what does it say? You guessed blah, blah, blah. And below that, we're actually going to go create our first match statement. And we're going to go guess, which is a thing that we defined earlier, right? The guess from the user. CMP for compare. And we're going to pass in a reference. Notice this is not a mutable reference, but it is a reference to secret number. Ordering. And we're going to access a variant. I think this is an enum anyway. Less in ordering. And this is, if you've seen like case matching in other programming languages like Python, I think the implementation details are ultimately different, but as far as the notation of what it looks like to the programmer is going to be very similar idea here of that you've got basically 3 cases, right? We're comparing 2 numbers. Either the left one is less than the right one, or it's greater than it, or it's equal to it. Those are basically the three cases, and under all three branches, we're going to define behavior of what happens so that we don't miss any of the cases. Ordering, we'll use greater, and we'll put in that print line, too big. That is, our guess is too big. And then the last case here to cover is equal. And equal, you win, because you guessed the number, because that's the point of this strange game. Okay. Mismatched types. Why do we have a mismatched type? Found a reference to an integer. I wonder if something is automatic. I wonder if the type thing is thinking that it's an integer. Oh, well, this issue right here can be solved by putting a bang to say that it is, in fact, a macro. But this is interesting. It's a secret. We're getting expected a reference to string, which makes sense based on the type. No, it doesn't make sense. Sorry, I'm looking at the wrong thing. We're looking at secret number. Secret number, yeah, secret number is an integer because it's generating a random integer from 1 to 100, so we need to cast it to a string. I'm sure the tutorial is about to tell us what a conventional way to do that is. It's probably like as string or something like that, but we'll see. Okay, let's jump in. So first we add another use statement, bringing a type called standard compare ordering into scope from the standard library. The ordering type is another enum. Okay, I was right. It's an enum and it has the variants less, greater, and equal. These are the three outcomes that are possible when you compare two values. Yes, it is. Okay, so then we add 5 new lines at the bottom that use the ordering type. The compare method compares two values and can be called on anything that can be compared. Isn't that a nice little sweet circular little bit of phrasing? But it has to do with traits and like what has implemented the compare method, which I think is related to saying providing like an impl for the comparison thingy. I don't know. Something. We'll get there. We'll get there. Okay. It takes a reference to do whatever you want to compare with. Here's it's comparing guess to secret number. Then it returns a variant of the ordering enum we brought into scope with the use statement. We use a match expression to decide what to do next based on which variant of ordering was returned from the call to CMP compare with the values in guess and secret number. So that's kind of an interesting thing that I'm not sure off the top of my head what I would want to do with it, but that last little bit there about the fact that this is a match expression and it's not just a statement. Notice that we don't put like a semicolon at the end. We don't need to anyways, because this evaluates, it becomes a value. All right. A match expression is made up of arms. So I think that that's probably each one of these is an arm. An arm consists of a pattern to match against. That's the enums that we've got. And the code that should be run if the value given to match fits the arm's pattern. That's whatever is on the right-hand side of those equal to, greater than signs. So Rust takes the value given to match and looks through each arm's pattern to turn in turn. Patterns and the match construct are powerful Rust features. You know me, I like powerful features. I'm never a big fan of the weak features. So they let you express a variety of situations your code might encounter, and they make sure you handle them all. Every single one. So these features will be covered in detail in Chapter 6 and Chapter 19, respectively. Yeah, I mean, these are important features of Rust, and I think it's one of the ways where you can make sure that you're handling all of the cases that you need to handle. I think that that can be quite important to say, here's an enum to match against, and you actually need to comprehensively cover all the cases. Or use an underscore to say all the other variants and things like that. Okay. So let's walk through an example with the match expression we used here. Say that the user has guessed 50 and the randomly generated number this time is 38. When the code compares 50 to 38, the compare method will return ordering greater because 50 is greater than 38. This tracks with my understanding of basic integers, yes. The match expression gets the ordering greater value and starts checking each arms pattern. It looks at the first arms pattern, ordering less, and sees that the value ordering greater does not match the ordering less. So it ignores the code in that arm and moves on to the next. The next arms pattern is ordering greater, which does match ordering greater. How about it? Identity. The associated function, associated code, in the arm will execute and the print too big to the screen. The match expression ends after the first successful match. It won't look at the last arm in the scenario. So in this sense, it's kind of like a, like an if, elif type of thing, but you're doing this pattern matching against an enum. Okay, so however the code and listing won't compile, we might as well give it a go. There we go. Do we get the same error? Previous error 308. Yep, they're both 308. Okay, wonderful. Good golly. All right, so the core of the error states that there is a mismatched type. Rust has a strong static type system. Delicious. And however, it also has type inference, which is also nice so that you don't have to write all the types everywhere when it's unambiguous. So when we wrote let mute guess be bound to the value of string new, Rust was able to infer that guess should be a string and didn't need us to write the type. That is nice. The secret number, on the other hand, is a number type. A few of Rust's number types can have a value. Let's read that again. A few of Rust's number types can have a value between 1 and 100, like I32, a 32-bit number, U32, an unsigned 32-bit number, and maybe when I say number, I should say integer. These are both integer types. I64 is a 64-bit integer, as well as others. Totally. Unless otherwise specified, Rust defaults to I32, which is the type of secret number, unless you add type information elsewhere that would cause Rust to infer a different numerical type. The reason for the error is that Rust cannot compare a string and a number type. Ultimately, we want to convert the string. To convert the string the program reads as input into a number type, so we can compare it numerically. Yeah, I think I got that backwards in my brain. I was thinking some silly thing of comparing the strings, but yeah, comparing the numbers is definitely the way to go here. Okay, the reason for, all right, ultimately, we do so by adding this line to main function body. All right, what do we got? We got the let mute string. That's already here. There's our standard in, read line, expect, and then looks like we've changed. What have we changed? We changed anything? We got gas. Yeah, I think this is fine. So we're shadowing. We're shadowing gas. We're going to give it a new value by basically replacing it. There's a few different things going on here. We're trimming it, which kind of removes any extra white space from the user, and we're going to parse it, which I kind of think is probably to say infer the type to int, but I can't say. We'll read the docs. We'll read the tutorial at least. Please type a number, so we'll put an expect. Now, if you remember from earlier in this tutorial, when you see an expect means that the parse function here is returning a result type. And so it will just be a correct value if it'll be an OK enum, and then your expect function will pull out the actual value out of the OK result. Or if it's an incorrect value, then it will basically crash the program. But before it does so, before it exits the program rudely, you got please type a number. Okay. And then you've got this print line macro that prints out your guess. Okay, and then we get down to the match case and compare, and we already talked about all that. So we should be good to go. So this line is let guess, and then we're annotating a 32-bit integer unsigned, bound to the value of whatever guess.trim.parse.expect, please type a number is. So we create a variable named guess. But wait, doesn't the program already have a variable named guess? It does. But helpfully, Rust allows us to shadow the previous value of guess with a new one. Shadowing lets us reuse the guess variable name rather than forcing us to create two unique variables such as guessStir and guess, for example. We'll cover this in more detail in Chapter 3, but for now, know that this feature is often used when you want to convert a value from one type to another type. You know, I don't think I even remember people in Python talking about shadowing that much, because like everything is kind of replaceable and the types are very flexible, so you just don't think that much about, wait, I could replace a value to the same name, but maybe with different content? Yeah, you can. Obviously, but like it's not a given. It's not a given. All right. So we bind this new variable to the expression guess.trim.parse. The guess in the expression refers to the original guess variable that contained the input as a string. The trim method on a string instance will eliminate any white space at the beginning and end. So if you've got white space in the middle, basically, then it will not get rid of it. If it's in the middle, meaning around some non-white space characters surround it. Okay, so which we must do before we can convert the string to a U32, which can only contain numerical data. The user must press enter to satisfy read line and then their input guess, and input their guess, which adds a new line character to the string. For example, if the user types 5 and presses enter, guess looks like 5 followed by a new line character. The new line character represents new line on Windows. Pressing enter results in those carriage returns, and a new line. So \r\n. The trim method would eliminate n or the /r/n, resulting in just 5. So the parse method on strings converts a string to another type. Okay, here when we use it to convert from a string to a number, we need to tell Rust the exact number type we want by using letGuess U32. That's where or how. Oops, I just clicked on some documentation. Sweet documentation. Okay, so we need to tell Rust the exact number type we want by using the letGuess and then the annotation U32. All right, so the colon after guess tells Rust will annotate the variable's type. Rust has a few built-in number types. The U32 seen here is an unsigned U32 or a 32-bit integer. It's a good default choice for a small positive number. You'll learn about other types in Chapter 3. Sounds good. Additionally, the U32 annotation in this example program and the comparison with secret number means Rust will infer that secret number should be U32 as well. Oh, that's nice, so that we don't have to go and annotate those types. Nice. So now the comparison will be between two values of the same type. Nice. The parse method will only work on characters that can logically be converted into numbers, and so can easily cause errors. For example, the string containing a thumbs up %, there would be no way to convert that to a number because it might fail. The parse method returns a result type, much as the readLine method does, discussed in handling potential failure with result. We will treat this result the same way by using the expect method again. If parse returns an error result variant because it couldn't create a number from the string, the expect will crash the game and print the message we give it. So that would be the please type a number part. If parse can be can successfully convert the string to a number, it will return the OK variant of result, and the expect will return the number that we want from the OK value. So let's run the program now. Let's do it. Let's just make sure that's saved, and we'll go cargo run. And look at that. The secret number is 27. Let's pick a number that's less than 27, so like 10. Our guess is too small. Let's pick, now the secret number is 42. Let's pick 42. We won. We won. Sweet. And then we'll go one more of going too high. So if the secret number is actually 13, let's put in 14. Guess is too big. Great. Pretty straightforward. Nice. So even though spaces were added before the guess, the program still figured out that the user guessed 76. Oh yeah. They tried it out in the example with some white space. Let's do the same. Let's throw some white space into it. So let's go space, 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 21, space, space. And we still won. That's nice. Cool. So that works as advertised. So we have most of the game working now, but the user can only make one guess. Let's change that by adding a loop. It's time to get loopy in here. So allowing multiple guesses with looping. The loop keyword creates an infinite loop. We'll add a loop to give users more chances at guessing the number. So it's back to one of those little snips where this code doesn't compile because it's partly, I think, oh, interesting. It doesn't actually have the Ferris saying it's not compilable. And I guess it's to say that if you wrote out all the code up to this point, it should actually compile. Yeah, but clearly the snip part there is not executable code. So I think they're just saying we're cutting out some details. So if I understand the code example here, up above there's the message for, you know, the secret number is part. So we'll put our loop just here. And then this loop goes all the way to cover actually the match statement as well. And look at that. The auto formatter just indented all of that for us. We didn't even need to do it. Not that it's hard to do in an IDE, but still kind of nice. Just keep writing code and it fixes the little things. So we got our infinite loop. Was there anything else we needed to add or change? It looks about the same, I would say. Yes, I think it all looks about the same. Okay, so as you can see, we've moved everything from guess input prompt onward into a loop. Be sure to indent the lines inside the loop another 4 spaces each and run the program again. I think that's an important thing for style. I don't think that it would actually break anything to not have those indents in Rust. So we run the program, the secret number is 97, so let's pick, I don't know, 23. Guess was too small. 24, still too small. What about 96? Nope, still too small. What about 99? Too big. Oh. So what you can see here is that we've achieved something where it's actually a feedback loop you can keep playing. Now you can see the silly thing is we just won, and it's still asking us for guesses. So the last thing that the tutorial's probably going to tell us about is how do we shut this thing off without basically hard breaking out of the program. Yup, let's continue. Okay, so the program will now ask for another guess, which actually introduces a new problem. It doesn't seem like the user can quit. The user could always interrupt the program by going Control-C, but there's another way to escape this insatiable monster. I didn't realize it was an insatiable monster, but that's good to know. Is it Ferris? Is Ferris the insatiable monster? Anyway, as mentioned in the parse discussion in computing the guess to the secret number, if the user enters a non-number answer, the program will crash. We take advantage of that to allow the user to quit as shown. So, okay, you could put in quit, but that wouldn't quit yet, right? Like we have to put that in. So try quitting. Try and quit will quit the game as you notice, so will entering any other non-numerical input. Oh, I see. It will actually, because of how we've coded up the just anything, like not just quit, but like quit blah blah will quit. Okay, got it. Okay. I'm on team that makes sense. So quitting after a correct guess. Let's program the game to quit when the user wins by adding a break statement. So here we're updating the match under the conditions of equal. So we're going to create a little localized scope here. We're going to add a curly bracket to say that this allows us to have some more instructions on what happens, basically. So we'll end this statement with a semicolon because you need to for statements, and we'll also create a break statement to say once you've hit the equal arm of this match statement, you print you win, and then break to break out of the program, break out of the loop, and then that's the end of the program when you break out of the loop. Okay, let's run it. So we got 44, 46, and then 45. It quits out. Wonderful. When you guess the right answer. Nice. Okay, so there's a good point here, which is up here it was saying, well, if you put in something, or up here, sorry, if you put in something invalid, it will also break out of the program. But maybe we don't want to break out of the program when we have invalid input, only when we put in either the correct guess. I'm not sure if they'll handle like maybe having a special quit command. We'll see. We'll see. Let's take a look. So handling invalid input. To further refine the game's behavior rather than crashing the program when the user inputs a non-number, let's make the game ignore a non-number so that the user can continue guessing. We can do that by altering the line where guess is converted from a string to a U32. What do we got going on here? So there's our IO string read line, failed to blibbity blabbity, let guess U32. And they're doing the trim match parse. But instead of calling expect, we're going to try to do something more with that return type. So remember, the return type, or the result type, I should say, has these two cases, right? It could be that it's an OK value, in which case we'll return the number, and otherwise we'll err. And this underscore in this specific context means just any value. Should be all right. I've messed up some piece of syntax here, though. Oh, it's kind of combining. Let guess U32 guess. It's a match, right? Right. This is a match statement, and that we're passing into the match whatever this result type is that comes out of parse. There we go. We got it. I got it. Hopefully you got it too. So we switch from an expect call to a match expression to move from crashing on an error to handling the error. I like that. Remember that parse returns a result type, and result is an enum that has the variants OK and error. We're using a match expression here as we did with the ordering result of the compare method. If parse is able to successfully turn the string into a number, it will return an OK value that contains the resultant number. That OK value will match the first arm's pattern, and the match expression will just return the num value that the parse produced and put inside the OK value. That value will end up right where we want it in the new guess variable we're creating. So if parse is not able to turn the string into a number, it will return an error value that contains more information about the error. The error does not match the OK enum number, or the OK variant of the enum pattern in the first match arm, but it does match the error underscore pattern in the second arm. The underscore is a catch-all value. In this example, we're saying we want to match all the error values no matter what information they have inside them. So the program will execute the arm's second code, continue, which tells the program to go to the next iteration of the loop and ask for another guess. So effectively, the program ignores all errors that parse might encounter. Great. So the only downside now of the current way that this code is written is that you can only correctly quit out by guessing correctly. And that's about it. Because if you put an invalid number in, it just continues in the next iteration of the loop. So there's no quit command if you're kind of like, you give up. But fortunately, there's only 100 options, so you're not going to go that long. Or you could just hit Control-C, because we all know that you can do that here. Okay, awesome. With one final tiny tweak, we will finish the guessing game. Recall that the program is still printing the secret number. That worked well for testing, but it ruins the game. Let's delete the print line macro that performs the secret, that outputs the secret number. Listing 2-6 shows the final code. The final countdown. There, it's gone. No more. Cargo run. So now, I don't know, like, how should we play a game like this? Binary search, I suppose. Let's say that I put in 50, and so it's too small. So then I'm going to guess, like, the next half is 75. Too big. I don't know if I want to, how precise I want to be, but let's just call it 66 is somewhere in the middle. It's still too small. So somewhere between 66 and 75. I don't know, roughly an okay guess would be 71. Too big. So somewhere between 66 and 71. Let's put in, I don't know, 67. 70. There, we won. I guess it's not that long of a game, because one, you don't have to exhaustively try all the options. And even if you're really sloppy about doing binary search off the top of your head, you'll probably still get there with something that's roughly binary search. Okay, so I think, let me see, we're not going to read through the example because we've been going through that the whole time. At this point, you've successfully built the guessing game. Congratulations. Summary. Maybe I'll move this out a little bit just because we're now reading only. So the summary. This project was a hands-on way to introduce you to many new Rust concepts: the let keyword, the match keyword, functions, the use of external crates, and more. In the next few chapters, you'll learn about these concepts in more detail. Chapter 3 covers concepts that most programming languages have, such as variables, data types, and functions, and shows how to use them in Rust. Chapter 4 explores ownership, a feature that makes Rust different from other programming languages. And Chapter 5 discusses structs and method syntax. And Chapter 6 will explain how enums work. So we went through all of Chapter 2. That is writing out this guessing game that provides a little bit of entertainment, I guess, and hopefully the Rust devs will update that deprecation warning for the tutorial. Update the tools they're using so it doesn't give a deprecation. But anyway, congratulations if you've been following along in possibly writing your first Rust program other than a Hello World program, something that's actually got a little bit of logic to it and a little bit of state to play with. And so with that, I will catch you in the next video, and I hope you have a great day. Bye.